Okay, just like I showed you in that demonstration, the number, excuse me, the number of moles of solute does not change when a solution is diluted. Therefore, the number of moles of solute before dilution is equal to the number of moles of solute after dilution. We had 2 drops of green food coloring. We added a whole bunch of water to it. I still only have 2 drops of green food coloring, correct? That's the same as moles. Now, how are we going to use that? Well, if we remember and rearrange our definition of molarity to solve for the number of moles. So if I rearrange to solve for moles, I know that the moles of the solute is equal to the molarity times the liters of solution. So by rearranging my equation, I come up with this equation. The number of moles of solute is equal to the molarity, capital M, times the liters of solution. Thus, my key equation for dilution is M1 V1 is equal to M2 V2. How am I able to do this? Well, it's because the number of moles are equal. It's something in I believe in your math they'd explain it to you as A is equal to B, and then B is equal to C. Therefore, A is equal to C. Correct? That's the same thing here. Right here. M1V1 is equal to a number of moles. This M1V1 is equal to the same number of moles. Therefore, they're equal to each other. So when I make my dilution, M1V1 is equal to M2V2. The question says, how would you prepare a 100 milliliter solution of 0.4 molar magnesium sulfate from a stock solution of 2.0 molar magnesium sulfate? Now, what I'm going to do is I'm going to set up the equation like we just had. M1V1 is equal to M2V2. Once again, M1 is the initial or the first molarity. V1 is the first volume, is equal to the second molarity, the second volume. Now, something I did not mention when we were writing down your notes is this whole volume thing. I have my volume up here in milliliters, correct? When we are doing dilutions like this, it is okay to leave the volume in milliliters just so you're consistent. What do I mean by that? Well, if V1 is in milliliters, V2 better darn well be in milliliters. Okay? You could even do later on Could you measure a volume by a drop? If you could have a way of measuring it, aren't we just comparing these though? Right? Could I add 5 drops over here and 10 drops over here? I would know that the volume is double if the drops are the same, right? If I use the same pipette, you will do that later on in class. Okay, it's called titrations. You will actually do that. So you could use drops just so you are consistent. Now, I am taking a 2 molar stock solution of this magnesium sulfate. So my very first one is going to be, my M1 is going to be 2.0 molar. Now, I do not know how much of that stock solution I need. So I'm going to put in parentheses V1 because that is my unknown. What molarity do I want to make? What molarity do I want to make? 0.4. And how much of that do I want to make? Well, don't convert it to liters. We don't need to. Just leave it at milliliters. So, using your math skills, can you solve for V1 here? Absolutely. We take and we divide by both sides by 2.0. So, when I come up, I have V1 is equal to 20. How many sig figs? I got 2 sig figs, so I put a dot after that. What's my label? Milliliters. So what I would do here, folks, if I were actually making this solution, I would take 20 milliliters of this 2.0 molar solution, and then I would, to that 20 milliliters, how many more milliliters do I need to add? How many total milliliters do I want? 100. So how many do I need to add? 80 milliliters of water. Okay, what I would do is I would pour 20 milliliters of that solution in a 100 milliliter volumetric flask, and then I'd fill it to the line. Make sense? Go ahead and write down the second example. I'll give you a second to come. Okay, my question here, this is similar to the first one. How would you prepare a 250 milliliter solution of 0.2 molar sodium chloride from a stock 1 molar solution? Once again, we're just going to do the M1V1 equals M2V2. Usually for my M1, when I'm making a solution, it's going to be my stock solution. So I'm going to use 1.0 molar. I do not know V1 again. I know that I want a 0.2 molar solution, and I know that I want 250 milliliters of it. Once again, I do not need to convert that into liters just so I have consistency. So when I solve for V1, I'm going to get how many sig figs? I see 2 sig figs, so once again, I got to put a decimal point there to have my significant figures correct. So, I am going to take 50 milliliters of the 1.0 molar solution. I'm going to put that into a 250 milliliter volumetric flask, and then I'm going to add distilled water until I get to the line to dilute it, and that will give me a 0.2 molar solution. Now, this last example, you are going to see this on WebAssign. So make sure that you copy this down because you're probably going to have questions on it when you see it on WebAssign. So I'll give you a second to copy that down. Now this example is a little bit different. I cannot use M1 V1 equals M2 V2 because I'm adding molarities of two different solutions. I'm adding volumes of two different solutions. So what I have to do is I have to determine the amount of moles in each solution. I know that moles of solute is equal to molarity times liters, correct? Now with this one, I'm going to convert my volume back to liters. So what I'm going to do is I'm going to determine how many moles I have of this first. So that one's going to be in the green. So I'm going to take 3.90 molar, and I'm going to multiply that by 0.1200 liters. When I do so, I come up with 0.468 moles. So the amount of moles of my first one is 0.468. Now in blue, I'm going to find the moles of my second solution. So I know that 3.40 moles, and I have 160 milliliters, so that's 0.1600 liters. And I get 0.544 mole. Are we with me so far? That wasn't anything new, was it? Now, in order to find my molarity of my final solution, okay, how do I calculate molarity? What's the equation for molarity? Moles of solute over liters of solvent. So, what is my total number of moles? I need to add those two together. So, I get 1.012 moles. So that is the number of moles in my total solution. Now, let me extend that down just a teensy bit, not quite that much. Okay. Now, folks, let's look at this. I know that my molarity is equal to my moles of my solute over what? The volume, the liters of solution. How many liters of solution do I have here? I add them up. So I'm going to do that over here. Add them up. 0.008 0.2800 liters. Add it up, correct? So I'm going to divide that by 0.2800 liters. Now, if I'm just guessing, where is my value going to be? What's my molarity going to be? Can it be greater than 3.9? No. Can it be less than 3.4? No. So it should be somewhere in the middle there, right? And I would say, since I've got a little more of the 3.4, that it'll be a little closer to that than it will be to the 3.9. And when I come up with my value for my molarity, let me go back up and look at sig figs. I'm seeing 3 sig figs. So when I come up with my value for my molarity, it is equal to 3.61 molar. So when I combine those two different molarities of the substance, I came up with a total molarity of 3.61 molar.